Hello and welcome to General Science Module 11, the human body. What I was hoping to do with this video is, since we're at home on a snow day and we need to keep going in our book and learn a ton of new things, thought I'd give you my lecture that I was going to give today and do it on video so that we don't have to do that tomorrow. And we can get into, we're going to do bone experiments, open up some chicken wings and look at muscles tomorrow, and then also crack open the little bones as well. So I wanted to go over the outline here so that we don't have to take the time to do that tomorrow, because then we will run out of time. This is quite a long chapter too. So the first one was, if you get your outlines out, please. These are the answers. And I'd like you to just follow along just like we do in class. And I'll talk through some of the things that that I think are important and or interesting, and you may or may not feel the same way. So their introduction is there any such thing as a simple life form? I really liked when he was talking about this, and just really I appreciate his Christian worldview in this book, instead of just throwing this at you and just not just saying how great the human body is and how amazing it is, but just really stop and think about, is there any such thing as a simple life form? I mean, the answer is absolutely not. And why not? And I think in the book it said because even the simplest life forms are amazingly complex. I mean, have we ever been able to make an amoeba? Have we ever been able to make any living thing do something that we wanted to do? Even a plant, for that matter. So I just thought that was an interesting thing to talk about. Okay, so we get into the human body, and we're talking, he calls it a superstructure of the human body, and there's 3 units: the skeleton, the muscles, and the skin, and all that is covered in this module in one thing. So it's definitely an overview of these things. I was going to spend one day on the skeleton, one day on the muscles, 1 or 2 days on the skin, and then we're done. So it's definitely not going super in-depth. So in the skeleton, the number of bones is generally regarded as 206. I think there's some debate. Babies have more before they fuse together. The answer is 206. Bone marrow in your bones, in your skeleton, which I think is interesting, produces cells in your blood. It produces your blood cells in there. And the skeleton has many jobs. The main ones is it supports the body. You can imagine if you didn't have any bones, you would look like Play-Doh, or not Play-Doh, Play-Doh, a jellyfish, just blobbing around. And then also protects the vital organs. You know that the strongest bones are protecting our organs. Your skull, super strong, protecting your brain. All your rib cage, protecting your internal organs, okay? Then the second part is muscles. We have 3 types of muscles, and whenever I think of this, I think of the song that I have in the 3rd and 4th grade class, and it starts off, and you don't have to memorize it, but it says, muscles of 3 types you'll find: skeletal, smooth, and the cardiac kind. All right, so skeletal muscles are the ones that move your body, all right? Smooth muscles are the ones that are in your internal organs and blood vessels. They work differently than skeletal muscles, and that's why they're different. And I have this to show you from my 3rd and 4th grade class. So this is pretending to be the muscles of your esophagus, or the muscles that are pushing your food down. Those are smooth muscles, and this is how they do it. This ball, squishy ball in here, is pretending to be your food. And the muscles are basically squishing it, contracting, and relaxing, and pushing food or blood through the tubes in your body. All right, so that's smooth muscles. The next one is cardiac. That is your heart, your cardiac. If you ever heard of cardiovascular, trying to think if there's any other. Anyways, cardiac is your heart muscle, super strong, pushing a lot of blood through your body. We'll learn about that later. The next superstructure of the human body is our skin. And the skin has 2 main functions. Protects your body, obviously, and it senses the outside world. Remember, we have receptors on our skin that help us sense the outside world. And I don't remember if it had it in the book, but I believe it's our largest organ, is our skin. All right, let's go to bones and get into those. I love this part. Bones are as strong as steel, but yet light as aluminum. Basically, there's nothing else in any other element in nature that is the same, that has the same strength and lightness as a bone. And so, and then there was this quote in there which I thought was great. Bone is made up from chemicals which are extremely weak, but nature mixes them together to create something very tough. So basically, if you just look at all the materials that are in bone, it doesn't look like much. But then nature, as in God, created it and put it together and makes it very strong so that we can run and jump and do all the things that we want to do. All right, this is important. Bones are made up of two things, collagen and minerals. Collagen, C-O-L-L-A-G-E-N, and minerals. All right, you want to know that the minerals, like calcium, make the bones hard. So it's the minerals that make the bones hard, and then the collagen gives bones their flexibility because the bones are also flexible. Otherwise, we would jump down off of a stair and everything would shatter. We need to have some flexibility. And then we're going to do experiment 11.1 on Thursday, and we're actually going to do it a little bit more than what they say. But it says, what can dissolve the minerals in bones? Well, we're going to put bones in vinegar, and we will see that the minerals will be taken away. And since minerals make the bones hard, then they will be, afterwards, they're going to be flexible. All right, so we're going to label these parts of the bone. So you have a different picture on here, but I was able to find this guy. So if you look at your outline, so you want to find the red bone marrow. And so this one doesn't have it, but the red bone marrow, I don't know if I can use this, is going to be in the spongy bone because the spongy bone has the red bone marrow. So you need to have an arrow here, and it goes to red bone marrow. The yellow bone marrow is the center, and we do have a picture that looks like this. It's in the center of it. Spongy bone is on the end where your red bone marrow is. And then compact bone is all around the yellow marrow. So it's in the straight part, and it surrounds kind of the spongy bone. And then we have the periosteum is basically the outside coating of the bone. All right, so you just have a line to the outside of the bone, and you've got the periosteum. All right, if you have any questions on that, we can go over that. I do want you to know how you can increase your bone mass. You'd think, well, there's nothing I can do because I just have the bones that I have. No, exercise and eating well are things that you can do, especially exercise, especially getting them stronger. Aerobic exercise can increase your bone mass. What is an endoskeleton? An endoskeleton is the sum, which is adding up all of the bones in your body. So your endoskeleton is basically all the bones in your body. Okay? Cartilage. Cartilage is related to bone, but it is not bone. You know what's made out of cartilage, right? Your ears and your nose. So it is more flexible than bone. If you ever see like a picture of a skull, like a dead person, and then they have the skull, there's no ears there, and there's no nose. There's like a hole where the nose is because that's the cartilage. And what does cartilage do? It's on the next bullet point. It attaches bones together, and then it also caps the parts of bones that form joints. All right. Next thing up is on the second page. You get to label these bones on your picture, and you won't use all of these lines because I just got this skeleton from online, so they thought you should know a lot of things, but this is general science, so I think you need to know some of the main bones. All right, so your clavicle. I will go ahead and just point on this and make sure that you get it in the right spot. So, clavicle are these things straight across, also called your collarbones. Definitely don't want to break those. Those are important. I guess you don't want to break any of them. Scapula is in the back, your shoulder blade, right back in here. So shaped like a triangle. Sometimes people call them your chicken wings. All right. Humerus, because the humerus is so funny, it's the long bone on the top of your arm. That's your humerus. Your sternum, chest, right here, protecting lots of your organs. Radius and ulna. Okay, radius you may know from circles. It's from the center of a circle out, but it is also a very important bone. So the radius and the ulna are the two bones in your forearm. Okay, so it's a little difficult to figure out which one is the radius and which one is the ulna. I believe that the radius is the bigger one. I'm not positive on that. Let me get back on that. Okay. Pelvic girdle, super easy to remember. It's, you know, where you'd wear a girdle. A woman from the olden days would wear a girdle. So that's your pelvis. Everything kind of sits in there. Your femur is your longest bone, top of your leg. Your patella is a fancy name for your kneecap. And then your vertebral column is all your vertebrae in your spine. All right, so I hope you would get those. And then the last part of skeletons is it talks about skeletons and other organisms. Okay, the definition of a vertebrate, which you can hear vertebra, invertebrate. It's any creature that has a vertebral column, okay? Any creature that has a spine, if you want to call it that, fine. Invertebrate, in that prefix means not vertebrate. It means that it's organisms from kingdom Animalia with no backbone, all right? So what they're saying here is an invertebrate without a backbone, you can have like a little amoeba, like squishy blob. He doesn't have a backbone, but he's not an invertebrate, okay? They have to be from kingdom Animalia with no backbone. And the examples that they gave, jellyfish, snail, and grasshopper. A snail has a shell on the outside, but it does not have a vertebral column, and neither does a grasshopper. All right, so then they talk about exoskeleton. Exo means outside of, so that means that they have a skeleton. It's a body covering, typically made of chitin, C-H-I-T-I-N, that provides support and protection. It's basically they carry their skeleton around their outside of them, like a snail or a grasshopper. And biologists call those types of animals, which have an exoskeleton, they call them arthropods. All right? On your own, page 273, let's go over this. 11.4, classify each of the following as a vertebrate, invertebrate, or neither. So it would be neither if it's not in kingdom Animalia. It's a vertebrate if it has a spine, invertebrate if it doesn't. All right? So a worm, that is a bug in kingdom Animalia. Does it have a backbone on the inside of it? No, it's just goopy. So it is an invertebrate, all right? We'll go to B, alligator. Is he an animal? Yes. Does he have a backbone inside of his little squishy thing? He does. So he is a vertebrate. C, grass. Is grass an animal? No. So he is neither an vertebrate or invertebrate. D, yeast. Is yeast an animal? No, it's a fungus. So it is neither. E, starfish. Is he an animal? Mm-hmm. Does he have a vertebra? Mm-mm. So he's an invertebrate. And then F is bass, which is a fish. They had to tell us that. Bass is a fish, and so that would be an animal. And fish do have backbones. If you ever opened one up, you could see it. So it would be a vertebrate. And a clam is an animal with no backbone, so he is an invertebrate. All right, hopefully I'll get to mussels. Enjoy your break.